All right, so I'm going to quickly go over the practice test that I passed out today. Hopefully, it was pretty straightforward. If you have any questions, please let me know prior to the test tomorrow, and let's get to it. So let's zoom in just a little bit. Okay, we're going to be graphing these, finding all the relevant information. So first off, my y-intercept is going to be at 0, comma 3. That's just that number right there. The x-intercepts aren't worth it, so I got my y-intercept. There's my first step. Second step, I'm going to take the derivative, so that's 3x squared minus 3. I can factor out a 3. I'm left with x squared minus 1. Set that equal to 0. So I have x equals plus or minus 1 for my critical points. So I can start doing my sign chart. Second derivative is 6x. So set that equal to 0. I get x equals 0. So I've got my second derivative sign chart right here. So I'm testing -1, I'm testing 0, and I'm testing 1. Hopefully I left enough room for each one. So my first derivative, testing left of -1. If I plug in a -1 here, I get, or -2, that's positive. A number in between would be negative, and a number to the right would be positive. For my second derivative, I'm testing to the left of 0, which would be negative, and to the right of 0, which would be positive. So, 0 is an inflection point. I have a max at -1, so I'm going to find out what -1 gives me. So I plug -1 back into my original function. I have -1 plus 3 plus 3. So -1 plus 3 plus 3 is 5. That's my max. My min is at 1, so I'm going to plug 1 in. I get 1 minus 3 plus 3, so that's 1. So my ordered pairs is -1, 5, and 1, 1. So from here, I've got enough information to sketch this graph. So I go up 3. There's my y-intercept. I know my max is at -1, 5. I know my min is at 1, 1. So my graph is increasing concave down. So increasing concave down. Then I'm decreasing concave down between -1 and 0. Then I'm decreasing concave up. So there's decreasing concave up. And then increasing concave up. So there's a sketch of f of x, given all of our relative information. Number 2, same thing. We can find my y-intercept really quickly. My y-intercept is, plug in 0, I get 0, which is one of my x-intercepts. I could factor out an x for my function. I have x to the 4th minus 5. And I could find my x-intercepts, but it's not worth it. And I say it's not worth it in there, so you don't have to. Okay, so first derivative is 5x to the 4th minus 5. Set that equal to 0, factor out a 5. I get x to the 4th minus 1 equals 0. If you want to do more factoring, that's x squared minus 1, x squared plus 1. This gives you imaginary. This is x plus 1, x minus 1. There's 5 in front. So my critical points are the real numbers, so I get x equals plus or minus 1. If I want to do my second derivative, I'm going to say it is, bring down the 4, you get 20x cubed. Set that equal to 0, so you get x equals 0. So then I go to my sign chart, double prime, split it down the middle, there's your 0, and it's going to look something similar. That's -1, that's +1, So pick a number to the left of -1 for the first derivative. So -2. -2 to the fourth is positive times 5 minus 5, so that's positive. If I plug in 0, I'm going to get negative, and to the right of 1 is going to be positive. For the second derivative, I'm looking left of 0, which makes that negative. To the right would be positive. So I've got my y-intercept. I can find my max and min. My max is going to happen at -1. So what's y of -1? It is -1 plus 5. So -1 plus 5. So that's positive 4. So my ordered pair is -1, 4. And my min is at 1. So it's plugging in 1 to my function. I get 1 minus 5, which is -4. So I have all of my information that I need. At -1, I'm at 1, 2, 3, 4. At 0, I'm at 0. At 1, I'm at -4. So I am increasing concave down. So increasing concave down, decreasing concave down, decreasing concave up, and then increasing concave up. So there is my function. Expect to see one of these, maybe an x to the fourth, to see if you guys can handle that for tomorrow. So there's the first part. Next up, I know I showed you this in class a little bit earlier. We're going to have to do the quotient rule 2 times on this. So it might look a little messy. We can first find our x-intercepts. So that's where the numerator is equal to 0. So that's x equals 0. And in fact, that's going to be 0, 0. My y-intercept, I plug in 0 and I get 0. So my x and y intercepts are both at 0, 0. I have a vertical asymptote at, if I factor the denominator, I have x minus 3, x plus 2. So I have vertical asymptotes at x equals 3 and x equals -2. And I have a horizontal asymptote at y equals 0. So that's all just information I know from the function itself. So the next step, our first derivative. Ho d high minus high d ho. Ho d high, so x squared minus x minus 6 times d high, which is 1, minus high x d ho, which is 2x minus 1, all over ho ho. So the nice thing about these ones is they're going to turn out to have the first derivative, wherever you have your vertical asymptotes, it's going to be the same thing in the denominator. So let's simplify. This is x squared minus x minus 6. That stays the same. This is minus 2x squared plus x. So my x's cancel, and I'm left with y prime equals negative x squared minus 1. Well, let's be careful. That's -6 plus 1, so that's -5, all over x squared minus x minus 6 squared. So once we have the first derivative, we're going to see what makes this 0. So we're going to set the numerator equal to 0. I got -x squared minus 5 equals 0. That means x squared equals -5. That's not possible, so nothing makes our first derivative 0. What makes it undefined is the same thing that made the first one undefined. So I have x equals 3 and x equals -2. So these are my critical points. Next up, and I'm going to do this on a second sheet of paper, I'm going to look at my second derivative. So what's the derivative's derivative? That's ho d high, so the bottom, which is x squared minus x minus 6 squared, times the derivative of the top, which is negative 2x, minus high, negative x squared minus 5, which I'm going to just distribute that negative, dho, which is 2x squared minus x minus 6, times the derivative of the inside, which is 2x minus 1, all over ho, which is x squared minus x minus 6 squared. Okay, so that's a lot of work. What I see, to make myself a little bit easier, this has an x squared, this has an x squared, so I can factor out a common x squared minus x minus 6. What's left is I have x squared minus x minus 6 times negative 2, negative 2x, plus I have an x squared here, I have a 2, and I have 2x minus 1. So I'm going to simplify this even more. It's x squared plus 5, 2, so that's 4x minus 2, all over x squared, that should be 4, minus x minus 6 to the 4th. So this is already starting to get a little bit ugly. So I have x, this is really x plus 2, x minus 3, times, this becomes x squared times negative 2 is negative 2x cubed, plus 2x squared plus 12x, plus x squared times 4x is 4x cubed, x squared times negative 2 is minus 2x squared, 5 times 4x is 20x, and 5 times negative 2 is negative 10. Okay, so I'm going to combine like terms. I have 4x cubed and negative 2x cubed, so that's 2x cubed. I have 2x squared and negative 2x squared, those cancel. I have 12x and 20x, so that's 32x minus 10, all over x squared minus x minus 6 to the 4th, which turns out those cancel. That's a 3. So really, I'm left with 2x cubed plus 32x minus 10, all over x squared minus x minus 6 to the 3rd. So that's a lot. And what we could do is we could find out what makes this 0 to get my possible inflection points. I'm going to have definitely at x equals 2, x equals negative 3, sorry, positive 3, negative 2. That's from the denominator. And this is too difficult to discern what's going to happen. I could factor out a 2. That would be x cubed plus 16x minus 5. And that's too difficult to factor. We could do it. It's going to be plus or minus 1 or plus or minus 5. So really, one of our zeros is, let's try 1. 1 plus 16 minus 5, nope. So it's probably going to be negative 5. So that's negative 125. 16 times negative 5 is negative 80. Minus 5. Not quite. Yeah. Don't worry about this part. These are what we're going to work with. For tomorrow, TOM10, RROW. Be able to do something like this. If you can graph something like this, it will make it a little bit nicer and easier. So let's finish this problem set up. I have my y prime line. I have my y double prime. I'm going to be checking x equals negative 2 and x equals 3 for both my first and second derivative. There may be one more inflection point for my first derivative, but I couldn't find that by hand. So I'm going to plug in my numbers. Left of negative 2 is negative 3. I'm plugging that into my first derivative. So that's negative over a positive. So that's negative. In between, let's try 0. I have a negative over a positive, which is negative. And to the right of 3 is a negative over a positive. So that's a negative. So everywhere on my graph, I'm decreasing. For my second derivative, to the left of negative 2, so if we get here, if I plug in negative 3, this is, let's see, negative 3, I get negative 27, negative 40, so let's plug in negative 3. I have 2 times negative 27 plus 32 times negative 3 minus 10. That's negative, 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 so that's negative on top. And on bottom, I have 9 plus 3 minus 6 cubed. So that's positive. So I'm left with a negative. In between negative 2 and 3, so if I plugged in 0, I get negative over a negative. Sorry, let's put that on screen. If I plug in 0 up here, I get negative over a negative, which is a positive. So that tells me my concavity. And then to the right of 3, I believe I'm going to get another negative. So what does this graph look like? At negative 2, I have a vertical asymptote. At 3, 2, 3, I have a vertical asymptote. To the left, sorry, I have a horizontal asymptote at 0. That's what we wrote. And I have an x and y intercept at 0. So, what does my graph look like? I want to be decreasing concave down to the left. And I want to be decreasing concave down over here too. So what's decreasing? Sorry, this is probably concave up. Decreasing concave up over here. And let's just double check. If I plugged in 4 to my second derivative, I would have 2 times 4 cubed plus 32 times 4 minus 10 over 4 squared minus 4 minus 6 cubed. 4 squared is 16 minus 10, so that's positive. This is 128 plus another 128 minus 10, so that's positive, yeah. So I have negative plus plus. That makes this here positive. And I know I'm most likely going to have another inflection point between negative 2 and 0. So if I tested left and right of 0 for my second derivative, if I pick negative 1, I'm going to get something that's positive. And if I get something here, my graph is going to look like that. These ones are more challenging. I want you to be able to find this type of information. Last bit. I like these. Expect this question on there. So, what I'm asking you to do basically make your sign charts from the information. So this says my first derivative is negative left of negative 2. So negative 2, that means that's negative. My first derivative is positive to the right of negative 2. So I am positive to the right. My second derivative is positive left of 0. So here's 0. Let's put a plus there. My second derivative is positive. To the right of 0, my second derivative is negative to the right of 0. So I'm asking you, what does this function look like? Increasing, concave up. Here's a picture of my function. At negative 2, from negative infinity to negative 2, I am decreasing concave up. So I'm going to be decreasing concave up. From negative 2 to 0, I am going to be increasing concave up. Increasing concave up. Then, to the right of 0, so that's negative 2, I'm going to be increasing concave down. So increasing concave down. So here's our sketch of what the graph would look like. Decreasing concave up, increasing concave up, increasing concave down. And then it just keeps going off. This is kind of like a log. So that goes over your practice test. Email me if you have any questions. Good luck. I'll see you tomorrow.